Hi everyone. Today I am doing this session on combining polynomials. So we're going to be talking about how you basically simplify things with polynomials, especially if you have multiple variables. So a polynomial is a single term or a sum of terms in the form a times x to the n. So there is a specific format for something to be a polynomial. So some examples would be 2x squared. So that's in the correct form. Now, if you have something that's 2x squared, that is called a monomial because it's only one term. Two-term things are called binomials. So an example could be 3x cubed minus 2. So the 2 doesn't have a variable, but that's still considered a polynomial, but the exponent would be 0. So that's a binomial. A trinomial is something that has three terms, like 3x cubed plus 4x squared minus 5x. So that is also a polynomial, and it has three terms, so that is specifically called a trinomial. Usually we write polynomials from the highest to lowest exponent. That's considered standard form. If you have your variable in the denominator, it is not a polynomial because that's not in the correct form. If your variable has an exponent that is a negative or a fraction, that is not considered a polynomial either. If there's a square root and a variable is inside the square root, that's not a polynomial. So there's a very specific form to things that are polynomials. So we have some terminology associated with polynomials. The degree of a term is equal to the sums of the exponent. I should put the S, sum of exponents on the variables. So let me give you an example. We can have a polynomial with multiple variables, like 2x squared y cubed. Because both variables are in our form, that's still considered a polynomial. This is a monomial because it's one term. So the degree of this term is 5 because 2 plus 3 is 5. So the degree of a polynomial is the highest degree of a term. So if I had multiple terms here, so the degree of the first term is 5. The second term here, I have an x cubed, y cubed. You add those, you get 6. The degree of that term is 6. So the degree of the whole polynomial is 6 because that's the highest degree. The term with the highest degree is called the leading term. Now, in this case, the highest degree is last. Generally, we put the leading term first, which is why it has the name leading term. And then the coefficient of that term is called the leading coefficient. So this is some terminology that you're going to need that is going to be used throughout this course in this section. Okay, so here are some examples. These are all polynomials. So the first one, I have negative a cubed plus 2a squared plus a to the 5th. So this has three terms, which makes it a trinomial. So we need to identify the leading coefficient. So that looks at the highest term, or in this case, the highest exponent. So that would come from the a to the 5th. So this is not in standard form. If we wanted to put it in standard, we put that first, and then we would have the minus a cubed and then plus 2a squared. So the leading term has the highest exponent, that's a to the 5th. There's no coefficient, so we can put a 1 there. So the leading coefficient is 1. And then the degree of the polynomial. So these are all one variable polynomials, so it's just simply the highest exponent. So the highest exponent here is 5, so this is degree 5. Okay, so now the middle example here, 7z plus 13z squared. So that has two terms, which makes it a binomial. And I'm going to rearrange this so that the highest exponent is first. So that's 13z squared plus 7z. Because that means then that 13, that is our leading coefficient. That is our leading term. And then the degree is the highest exponent. So since the highest exponent is 2, this is degree 2. And now the last example here is 23. So that is one term, so that is a monomial. There's nothing to rearrange here. If I rewrite this, pick any variable, this would be as if you had a variable with a 0 exponent. Or basically that means the exponent is non-existent, or the variable is non-existent. So if you write it that way, you can see that the leading coefficient is 23. Now, normally we don't use this terminology if we just have things with numbers without a variable, but it is good to see that even numbers can be considered polynomials and they follow the same rules. And this is considered a degree 0 because there's no variable at all, so the exponent on that is 0. So now we're going to simplifying these. So when we're simplifying, we are basically just combining like terms. What we've had to do previously with like terms is that you combine the things that match, and they have to match with the letters and the variables, including all the exponents. So we talked about this, I believe it was week 2, and it was on the week 2 quiz, and I know a lot of people struggled and they got that wrong. We're seeing it again here. Things are like terms if they have the same letters and the same exponents on those letters, the same combination. The order of them could be written, they could be written in, excuse me, I'm going to take a drink. So the order of them could be reversed. It could be B first and then A, but they're still like terms. Because here, so on this first example, minus 5ab cubed plus 17ab cubed, both terms have A, both terms have B, and the exponents on both the A and the B match. So those are like terms. So when we simplify, we add the coefficients. Negative 5 plus 17. So that is 12. And then remember that the variables hang out. We're not combining, we're not multiplying A and B together because they're different letters. So they just hang out there. We don't add exponents there because we're not multiplying these together. We're adding. Now the second one here, we have 4c squared d cubed plus 3cd minus 10c squared d cubed. So we have parentheses here. This is just indicating that we basically are taking a monomial and we're adding a binomial to it. So the parentheses are unnecessary other than just to show how you are combining polynomials, because we have two polynomials added together. But normally we ignore that and we just simply write it exactly as written, because as long as the parenthesis doesn't have a number and it's a positive, it's unnecessary. So if you ignore those parentheses, this looks like a trinomial. So we want to combine like terms, and that is the terms with the c squared d cubed. They have the same letters, same exponents on those letters. So 4 minus 10 is negative 6. So we have negative 6c squared d cubed plus 3cd. Now, just to go back to our terminology, the first term here, when you add those exponents, you get 5. So this is degree 5, and it's a binomial after we combined like terms. Example 3 here, the first one on the left, we have two trinomials getting added together. Because they're in parentheses, that's what's indicating that we are adding polynomials, combining them together. So we have minus 3w squared plus 4w minus 6 plus 2w squared plus 4w minus 10. So because both sets of parentheses don't have any numbers in front and there's no negative signs in front, then they're completely unnecessary. They're just there to help us see what we're actually doing. So I'm going to just rewrite it without it. And now we're going to combine like terms. So I'm going to color code what are like terms. So the w squareds, those are like terms. The 4 w's on both sides, those are like terms. Or I shouldn't say both sides because they're not, there aren't different sides. And then we have the minus 6 and the minus 10. So when we combine these, I'm going to go like term by term. So the minus 3w squared plus 2w squared. Negative 3 plus 2 is negative 1. So that's minus 1w squared. And then I have 4w plus 4w. 4 plus 4 is 8. So that's 8w. And then negative 6 plus negative 10 is negative 16. So now we have added two trinomials and got another trinomial out when we combined the like terms. Now the next one here, 50yz to the fourth minus 14yz to the fourth. Those are like terms. They both have y, they both have z. The exponents are the same. So we do 50 minus 14. So that would give us 36yz to the fourth. Now we're going to do some subtraction of polynomials here. So when we're doing subtraction, we've got a minus, and so we have to distribute that negative through before we do anything. So we're really going to be using the distributive property. So I'm going to actually put a number 1. I'm going to do that in a different color so that shows up a little better. So whenever I have a negative, and I'm going to do that for both of these, you can just try to put a little 1 there so that you can see that you are multiplying a negative 1 through the parentheses. I should have given myself a little more space here to write those 1s. So for the 4z plus 3v minus negative 3z plus v, the first set of parentheses, I don't need to do anything. I can just ignore them because there's no negative sign or number in front of them. The second set, that's where I need to distribute. So I'm taking that negative 1 and multiplying it through. So negative 1 times negative 3, that's a positive 3, so that's plus 3z. And then a negative 1 times v, that's minus 1v. So now, like terms, we need to match the variables. So I have 4z and 3z. And then 3v minus 1v. So you have to make sure you're matching your variables. So with the z, 4 plus 3 is 7. So that's 7z. With the v, 3 minus 1 is 2. So that's plus 2v. And then they're different letters, so those cannot be combined. Now on my second side here, I've got 25m to the fourth minus, and then parenthesis, 23m to the fourth plus 14m. So I need to distribute that negative through the parentheses. So first I have my 25m to the fourth. Then negative 1 times 23m to the fourth would be a negative 23m to the fourth. And then negative 1 times 14, that's a negative 14m. So now highlighting my like terms, those are the m to the fourths. So I have 25 minus 23, which is 2. So I have 2m to the fourth minus 14m. So when we're combining polynomials, we're really not doing anything different from what you've done before. We're simplifying by combining like terms. We're still following the order of operations, doing our distributing, and then combining like terms, and doing everything you've done before. We're just basically using different language for particular types of these types of problems when they're in a specific form or they have a certain pattern. So that's all we're doing when we're talking about adding and subtracting polynomials. It's just a specific type that we are simplifying. So if you have any questions, you can give me a call, you can email me, you can send me a chat message. The next live session is going to be Monday at 11 a.m. where I'm going to go over multiplying polynomials. All right, I hope you guys have a great weekend, and I will talk to you later.